Hey guys, welcome back. Today Michael's going to talk to us about the time of concentration and show us how to calculate that in Hydro Studio. The time of concentration is the amount of time it takes for water to flow from the furthest portion of a drainage area to the outfall location. In other words, it's the amount of time it takes for water to be collecting all in one point from all portions of the drainage area or the drainage basin at the same time. So if it's a really large drainage basin, by the time the water collects from the furthest portions, the rain may have already started to slow down. And so in that case, having a longer time of concentration is going to make the flows less. In a smaller drainage basin, the water will flow to one point of exit really quickly. It collects from all over very quickly. And so you're going to have higher flows with shorter times of concentration and lower peak flows with longer times of concentration. So let's learn from Michael as he shows us how to calculate the time of concentration.
Hey, it's going to be a video showing how to calculate your time of concentration for this example, it's a pre-development basin. So the time of concentration is the amount of time that it takes to get from the most remote point of your basin to your study point. So you can see here's our pre-east basin on the right side that we'll do the example for. And this is our study point down here. So we started down at the study point, and you can go uphill until you get to the like the most remote point, or the point where it's going to take the longest for flow to get down there. So this is the path that we drew. It's 435 feet. If you go into Hydrology Studio, which was the previous video, and we set up our basins and put in our rainfall, we put the TC in at first for 10 minutes, but now we're going to use the TR55 method to calculate the TC. So if you click on your basin, pre-east basin, you change the TC method to TR55, click these three little dots. It will pop up the TR55 worksheet, which is comprised of sheet flow, shallow concentrated flow, and channel flow. Sheet flow is the first 100, the max sheet flow you can do is the first 100 feet of the flow path, even though if it's technically continuing as sheet flow, it's kind of enough flow to consider it as shallow concentrated flow. So we'll put in the 100 feet max, which it says that there as well. Your Manning's coefficient is the type of overland flow that the sheet flow is going on. So if you look at your Manning's table for this type of flow, we could say it's short grass, which would be a Manning's coefficient of 0.15. 100 feet of sheet flow, the 2-year 24-hour rainfall event, which we can pull from the NOAA table, 2-year 24-hour 3.76. If you put your rainfall data in correctly into Hydrology Studio before you start doing this, it will pull the number straight from it. So that's why it already says the correct number. And then you find the slope. So this first 100 feet over here, that's way too long. That was 212 feet. So there's 100 feet right there. We're going from 68 to about 66. So it's 2 feet over 100 feet, which is 2%. So you can type in your slope, 2%. And then if you hit apply, it will give you the amount of time that it takes to do that 100 feet of sheet flow. If we change our Manning's coefficient to a lower number, instead of short grass, like if we say it's actually overland flow, smooth surfaces, and you say it's like bare soil or concrete, so that'd be 0.011 apply, you see it decreases the flow time quite a bit. So let's confirm what that overland flow would actually look like. So here's the site. I mean, it looks like short grass, but then there's also some like bare soil mixed in as well. So I feel like it's not quite all the way up to the short grass of 0.15, but it could be somewhere in the middle. Yeah, let's do 0.011. That's fine. And then for the neck, after the first 100 feet, you go to shallow concentrated flow or channel flow. If you start in a channel, just start with channel flow. Channel flow is if you're in like a ditch or a pipe. Shallow concentrated flow is if you're over that 100 feet of sheet flow, it changes into shallow concentrated flow. A lot of times you have all three. In this instance, it looks like we'll just have sheet flow and shallow concentrated flow, since there's not like a well-defined ditch or anything that this is flowing in. So if our total length was 435 feet, that means our 435 minus 100, so it's 335. And then we say it's unpaved, and the slope would be from 66 to 56. So that's 10 feet over 335 feet. So that's 2.9%. Apply. So you see these Manning's values will change your TC quite a bit depending on what you claim it is. So that's really important to get that right. We may use short grass. The more I look at it, I feel like it should be short grass. So we're gonna do that. So that was 0.15. Apply. So our TC in total is 11.07 minutes, and we were kind of estimating before that it'd be 10 minutes, so we were pretty close. So now if we hit apply and close, it will have the number in right there, and you'll want to do the same thing if you were doing this site here. You'd want to do the same thing for the west basin, and same thing for the post basins as well.